Hello everyone, let's solve problem 5 from backtracking palindrome partitioning. You will be given a string of yes, divide the string into partitions of yes, and every substring of a partition is a palindrome. Let's see here, we have string AAB. Let's see how many partitions we can make. One is A, and B. If you see here, my partition is equals to S, and every substring of a partition is palindrome. Similarly, we have one more combination where A and B. Here my partition is equal to S and every substring of a partition is palindrome. It's a very good problem from backtracking. Let's see how can we solve it. We know that every string character can be accessible through index, where index number starting from 0 to n minus 1. So we initiate a recursive call with index 0 and the empty list. Now we have a possibility starting from current index to n minus 1. So our start index can be 0 or 1 or 2. Now see, our caller index is 0 and we are moving towards start index 0. With 0 0 combination, we can get a substring from yes as A. As A is palindrome, we add string A to the list. Then we initiate a recursive call to the next index from start index 0, which is going to be 1. Now from call stack 1, again we can iterate from current index to n minus 1. So we can start from index 1 or index 2. Let's go towards index 1. Now you see my call stack index is 1 and the start index is 1. With 1 1 combination we can get a substring from yes as A. And string A is palindrome, so we add string A to the list again, so we get AA. Now from start index 1 we can make a recursive call to the next index, it will become index 2. Now from call stack index 2 we can move towards start index 2. So we add start index 2 value to the list. Obviously if you see my caller index is 2 and my start index is 2, with 2 2 combination we get a substring from yes as B. As B is palindrome, we add string B to the list. Now our list becomes AAB. Now from start index 2, we make a recursive call to the next index. Now index becomes 3, which is equal to string length. It means we reached the base case, so we clone the current partition, then add to the result. Then we return to the caller, then we remove the last element from the list, so you will get a list of A comma A. Now from call stack index 2 we are done with all possibilities. So it's time to return to caller, then remove the last element from the list. You will get a list with A. Now from call stack index 1 we are done with processing start index 1. Let's go towards start index 2. Now closely see, my caller index is 1 and start index is 2. With 1 2 combination we get a substring from yes as AB. As AB is not palindrome, so we skip the current iteration. With this we are done with all possibilities from call stack index 1. It's time to return to the caller. Then remove the last element from the list. You again get empty list. So now from main caller we are done with processing index 0. Let's go towards index 1. Now my main index is 0 and the start index is 1. With 0 1 combination we can make a substring from yes as AA. As AA is palindrome, we add string AA to the list, then we make a recursive call to the next index, which is 2. Obviously from index 2 we can start with index 2. So my caller index is 2 and the start index is 2. With 2 2 combination we get a substring as B. So as B is palindrome we add string B to the list. Now it becomes AA comma B. So Then we initiate a recursive call from start index 2 to the next index, which is going to be 3. As the current index value is equivalent to string length, so we clone the list and add to the result. Then we return to the caller, then we remove the last element from the list. So with this, from call stack index 2, we are done with all possibilities. It's time to return to its parent, then remove the last element from the list. You get an empty list again. With this, we are done with processing index 1. So we move towards index 2. Now you see our caller index is 0 and the start index is 2. With 0 2 combination, we can get a substring from S as AAB, which is not palindrome, so that we skip the iteration of start index 2. With this, we are done with all possibilities. So we figure out the possible permutations which can be AAB and AA comma B. That's it. So hope you like the explanation and you crack the algorithm here. So let me walk through the code. If you see, the input is going to be index 0 as an empty list and you have empty result. So our backtrack method includes 4 parameters. First one is our index, second is the given yes and list of strings, and you have result. As a first statement, we will verify whether the current index is equivalent to given s length. If so, we clone the current list and add to the result. It means we got a partition. Otherwise, we initiate a start index as current index, we move towards s dot length, and we just increment the start index. So we see if current caller index to current start index is palindrome. If it is palindrome, we take it as a substring, add it to the list, then we initiate a backtrack call to the next index, which is start index plus 1 with the updated list. Once we are done with recursion, we remove the last element from the list. So if you closely see our palindrome logic, it is very simple. We take a s and start and end index. We move towards start less than n. We check whenever our starting character not equal to ending character, we return false. Otherwise, we increment start, decrement end. If everything goes smooth, we just return true. So this is a simple logic. If you didn't get this, please go back through the recursion flow, see how the call stack is happening. Once you understood that recursion tree, this code is nothing for you. So let me go and explain the time complexity. If you closely see, in worst case, every substring of a given string is going to be a palindrome. It means in worst case you can make 2 power n substrings from a given string, and on every recursive call we are cloning the substring into the list, so obviously our time complexity will be n into 2 power n. And space complexity here is, I'm only concerning about active stack frames can be number of stack frames can be active at any point in time, which is equivalent to given input length. So the space complexity will be big O of n. So that's it. So hope you like the explanation. If so, please click on like and subscribe. Let me go and submit the solution. Yeah, this is a simple code which I explained earlier. So you see, this is a empty list and this is empty result. We initiate a backtrack call with index 0, empty list and empty result. Whenever our index becomes s dot length, then we just clone the partition. Otherwise, we initiate a start index from current index, we move towards s dot length. We see whether the current parent index to current start index is palindrome. If so, we add to the list as a substring. Then we initiate a backtrack call to the next index with the updated list. Once we are done with backtracking, we remove the last element from the list. That's it. So let me submit the code. So hope you like the explanation. Thanks for your time. Please do subscribe and share.